Hello, this is your course instructor Khushwant Fatnani. Let us start off the day with the chapter Waves. Let's read something very beautiful about it, and of course, practice past year questions and see the distribution. So as we are starting this second part of the unit, Oscillation and Waves, that is waves itself, let us first write down the heading. We have oscillations and waves. All right. So like always, whenever we begin our session, let us join together for a short prayer and meditation. So I request all of you to kindly join your hands, close your eyes, a broad smile on your face, and let's begin. Take a deep breath in. Slowly a deep breath out. Once again, breathe in. Slowly a breath out. One more time. Take a deep breath in. And a deep breath out. Once more, let the smile stay on the face. Take a deep breath in and a deep breath out. Let us all pray. Dear God, we are your children. We thank you for such good health, wealth, and wisdom. Thank you for your favor on me, my education, career, finances, my family, my health. Thank you. Thank you for your favor on my health, wealth, and wisdom. I thank you in advance that I have cleared JEE Advanced 2020. I thank you in advance that I've cleared NEET 2021 in flying colors and have got the admission into one of the best colleges of my dreams. This dream is given by you, and I believe and have faith. The strength to reach this is also being given by you. With smiles on our faces, let us open our eyes and let us begin. Okay, oscillation and waves, and we are seeing the chapter waves today. So let us know one by one what you all know about this. Let us start from Anukriti. Yes, Anukriti, can you tell what are waves and what did you know about waves? Yes, whatever words you can recollect from your past experience with this chapter. Yes, Anukriti. Yeah, go ahead. If not, we'll start with Atul. Yes, Atul.
So in wave, we learned about speed, sound wave.
Mm-hmm.
Uh,
So there are some terms that we are recollecting from the past. This is the first part. Let us recollect. Yeah. Okay, you have something called as wave speed. Very good, very good. What else?
Sound wave.
You told about an example of a kind of wave which is called sound wave. Okay, what next? Anything else that you can recollect from the past?
Mm, Displacement.
This
Harm.
harmonics. Okay, okay. So how about you, Anukriti? Try just some terms that you could recollect.
So they have crests and troughs.
We have crest.
There are
Okay. Yeah, go ahead.
we have transverse waves and longitudinal waves.
Hmm.
And we have electromagnetic waves, which are both.
We have transverse wave and longitudinal waves. Okay.
And mm,
Then we have also something called as electromagnetic wave. Okay, such a fancy name. Electromagnetic wave. Okay. Okay. Yes, tell me more. Anything else?
uh, so the distance between two crests gives us the wavelength lambda,
Lam-
and
Absolutely. Absolutely. So distance between two crests, that is, if this is your wave and here you have two crests, then the distance between them is lambda. Absolutely correct. And it's termed as wavelength. Very good.
uh,
Good. Right. So, yes, excellent. Excellent. I'm happy to know that you both have some good memory from the past, right, which involves some of these questions which we have just seen. So, let us move ahead of this and learn something more, right? Just give me a second. Right. So, as I was saying, let us talk about first the distribution from this chapter. How many questions every year are asked. So, around sometimes, like I'll give you an example. So, we are seeing the distribution, right, in every year's paper. So, sometimes, so when it was in the early years, that is in the 2000s, 2001, 2002 and 7, in those years, if you talk, let's say in 2007 there were two questions which were asked from this, right? When you talk about 2011, then this chapter had, in fact, this chapter saw many questions. So in 2011, from this particular chapter, right, you had quite a good number of questions, as I can see, around oh, around 2 to 4 chapters were all okay. I think, just a minute, pardon me. Yeah, yeah, just a second. So I'm talking about the distribution, right? I'll recorrect myself. We have around two, yes, around 2 to 3 questions, particularly from this chapter, right? Sometimes 1 to 2 questions are also asked, right? Sometimes between 1 to 2 questions are also asked. So on an average, you can take 2 to 3 questions almost every year are asked from this chapter. So let us talk about, let's say, JEE Main 2013, right? So in 2013, you had 2 questions coming up, popping up from this chapter, right? Two questions popping up from this chapter. Similarly, for AIEEE 2012, for AIEEE 2012, we had again two questions popping up from this chapter. 2011 saw, I think, so in 2011, I don't know if it's from different batches, but we have quite good number of questions popping up from this chapter, right? So this is how things go. Then 2009, talking about 2009, again you have 3 questions popping up from this chapter. In 2008, also I can see that there are 3 questions popping up from this chapter. Let us take around 2 to 3 questions, right? Has been a trend coming up from this chapter, right? Let's move ahead and talk something about waves. By the way, if I write wave equation, I'm writing something here, right? I'm writing something here. See what I'm writing. A is equal to sine kx, right, plus minus omega t plus minus y. So Atul, can you look at this equation and try to establish some kind of relation or tell me some kind of analogy between this? And I say that this is the equation of a progressive wave. I say that this is the equation of a progressive wave, a wave which is moving. Can you think something about its relation with SHM? Yeah, tell me.
So SHM is a sine omega t plus phi. So
SHM is a sine omega t plus minus 5.
plus minus 5.
And here we have,
So the
what is the difference? What is the analogy? Can you try comparing how they are same and how they are different? The equation of SHM and equation of SHM. SHM and progressive wave. Yes, try thinking.
we have external kx in the equation of progressive wave.
This kx is something which is different, and the other terms are the ones which are same in the equation of SHM and wave, right? That is why both of them are under the same unit, oscillations and waves. Let us read and understand more about them. Okay, so we'll start from this point itself, right? That first of all, let us understand that what are waves, what are different kind of waves that we talk about. So what is wave? First of all, wave is nothing but propagation of energy from one point to another. Propagation of energy in the form of a disturbance from one point to another. So if I tell you to define wave, you can say that it is some kind of disturbance, right? Some kind of disturbance which is transporting energy from one point to another. Right? So a wave does the task of transporting energy from one point to another, right? One point to another. So this is what we understood, or this is the first concept of wave that we must know. Now, next one. What is the next concept that should be known is what are the different kinds of waves? So as Anukriti has just told us that, sir, we have the waves classification into some different aspects, right? One is called as transverse wave. So let us see the classification of wave. The waves are classified first on the basis of direction of propagation. See here, first classification is on the basis of direction of propagation. Or classical waves, right? So let us see them first. It's called transverse. When is it called transverse? Transverse, the word is itself means perpendicular. So what is perpendicular to what? So a wave which is traveling in a way such that the particles of the particles of the medium through which the wave is traveling, they are oscillating, let's say in the vertical direction. They are oscillating in the vertical direction, right? But so the particles are oscillating in the vertical direction, but the wave is traveling, in the forward direction or horizontal direction. So if the wave speed is in horizontal direction and particle speed is in vertical direction, then such kind of a wave is called transverse wave. To be very honest and precise, we can say when the wave speed and particle speed are perpendicular to each other, such a motion or such a kind of wave is described to be transverse wave. Where next one is called as longitudinal wave, right? So longitudinal wave is the one in which both the particle as well as wave are moving in the same direction. So if the particle is oscillating in the horizontal direction, if the particle is oscillating in the forward direction or in the horizontal direction, and the wave is also moving in the same direction, then we call such a wave as longitudinal wave. Very clear. Now let us see second kind of or second category of wave. It is defined on the basis of medium requirement. So this was on the basis of direction, and the next one is on the basis of medium. So how do you define it? You define it in terms of two types of waves again, right? One is called as mechanical waves, right? So what does mechanical wave mean? Any wave which requires a medium, to travel is called mechanical wave. Whereas a wave which does not require a medium, so a wave which does not require a medium will be called as non-mechanical wave. Note it down, class. Right? So we'll have this one, does not require a medium. So this is how we understood two very important concept about waves. Let us see the equation or the wave equation, right? So there is something called as wave equation or a general equation of a wave. How do you represent it? Let's see that, right? So as I just told you, a wave is represented by a particular form, right? Of especially in terms of displacement. So let's see what that relation is, right? Now that relation which is shared between displacement of the wave and x and t. So any kind of wave, let me first tell you, is not only, as Atul just cited, is not only just a function in time, it is also a function in x. So what are we trying to say? This is also a function in time and x. That is, if y is telling me about the displacement of the wave, right, vertical displacement of any particle of that wave, then x is telling me about its horizontal displacement, and time is telling me about at what time or at what instant of time am I observing this y value, right? So that is to say, if I draw a wave here, have a look. If I draw a wave, let's say this one. Let's say I'm drawing a harmonic wave. Harmonic is, Atul, what does harmonic mean? Can you tell all of us?
So in a specified way.
Harmonic is sine or cos. Anything which happens in terms of sine or cos is called as harmonic. Remember
Harmonic.
when we have learnt about
Yes, sir. Yes.
I told you all, simple means
Yes, sir. Yes, sir.
constant amplitude. Harmonic means something which is in terms of sine and
Sine.
cos, right? So when I'm talking about a harmonic wave, I mean which is sinusoidal. So such waves, no, which have such kind of curvy nature in sine and cos terms, right? Such waves are called as harmonic wave or sinusoidal waves. So such waves are called as sinusoidal waves. Good. So now if this represents y, right, then I can say that every point on the wave will have some value, right, which will have some value which is specific to a time and which is specific to a time and position, right? So this, let's say I can also denote x on the horizontal axis. I can also take t on the horizontal axis, right? With both x and t, y is varying is in this specific case sinusoidally, right? But in general, you can express any function of the type y is equal to f of plus ax plus bt called as wave. This is a general form of wave equation. Please note it down, class. Y is equal to ax plus bt is the general form of wave equation. Written. All right. Now, let's see something more about it. Okay. So now, as we have seen a specific kind of, as we have seen a general kind of wave, right here, suppose this is there, no? Suppose I ask you to find out what is wave speed. What is wave speed? So in order to write the wave speed, we change this form into something like this. Have a look. Y is equal to f of, make sure that the coefficient of x is 1, right? And coefficient of t is v, then v is called as wave equation. V is called as wave speed. Note it down, class. So by the comparison, what you can get that v is nothing but b by a, right? Where v is nothing but b by a. Written. See one more thing. Now there can be two cases possible, right? If we are, let's say, talking about x and y axis, and say y axis is in the upward direction, x axis is in the horizontal direction, and I name them, let's say this is y and this is x, and I talk about an equation y is equal to a sine kx plus omega t, right? And I talk about an equation y is equal to a sine of minus kx minus omega t. Then again, I talk about a particular category of equations as y is equal to a sine of kx minus omega t, and here y is equal to a sine of minus kx plus omega t. Anukriti, can you try to categorize these two by your observation? What do these equations imply? What do we mean when I'm writing things of this sort? Any correlations, any like any kind of relation between them, analogy or difference? What can you cite? Yes, try thinking about. Just look at the phase of the wave, this part, and try differentiating between them or establishing some analogy between them. Yes, go ahead.
Sir, in the minus kx parts, we have negative
So
displacement.
I'll say there are two things, two parts of it, A and B. What is the difference and
Yes, sir.
similarity between A and B? Yes.
Uh,
Atul, try it out. Any similarity can you
Yes.
cite? or any difference between?
As a sign.
Ah, excellent. See here. I think Anukriti, you're also very close, right? See here, both the terms have same sign, right? Both terms have same sign. See in the phase. In phase for A, in phase, both terms have same sign, right? What about this one? Anukriti, now try. In phase, both terms have
Opposite signs.
good. Both terms have opposite signs. So, what do I understand by this is that whenever whenever both terms in the sine or cos expression, you can have cos also, right? In sine or cos expression, right, have same direction or same magnitude, same signs, right? Then the wave is traveling in along positive x-axis. Wave is traveling along positive x-axis if both have same signs, right? Just a second. Oh, sorry, pardon me. If both have same signs, then the wave is traveling in the negative x direction, this way. And if both have different signs, then the wave is traveling in the positive x direction. Am I clear? The opposite signs, positive x. Then same sign, negative x. Will this be clear? Will this be remembered by both of you? Pakka?
Yes, sir.
Okay. This has to be remembered, okay? Now, coming to the next point, let us talk about a specific kind of wave, which is, of course, this is, now what kind of wave is this? This is said to be a progressive wave. What do we call it? It is progressing. It is progressing in a particular direction, either negative x or positive x. It's called a progressive wave. I hope you all are able to recollect, right? I hope you both are able to recollect with whatever we are reading, right? Okay. Now, let us talk about other different aspects of an equation of a wave. So, as I write y is equal to a sine omega t plus minus ax plus minus phi. What do we mean by this? Let us try to think about different terms. This y is called as displacement, right? It's called as displacement. What is A? A is the amplitude. A is the amplitude. Then, what is omega? Atul, omega is
Angular velocity.
angular frequency.
Frequency. Oh, sorry.
Angular frequency.
Angular frequency. Yes, sir.
Angular velocity, we talk about it when you talk about rotational motion. You were,
Circular motion.
yes,
Rotational motion.
when you talk about rotational motion, right? So this K, what is K here? It's called as wave number. What is it called? Wave number. It's a new term because it is chapter is wave. So this K is very specific to waves only. It's called as wave number. What about phi? Anukriti, can you tell us what is phi?
Phase constant, sir.
Very good. Phase constant, or it can also be called as initial phase angle.
Phase.
Initial phase or initial phase angle, whatever. Initial phase angle, or phase constant, right? Yeah, I expect both of you must be writing this, everything that we have written on board, right? Now let us define them again. Of course, we know amplitude is the maximum value of displacement, or y max, correct? Here, angular frequency is nothing but 2 pi by t, or we can also write it as 2 pi f, right? Correct? So this is one thing. What is next that we know? This wave number or k, right? This wave number or k, how do we define this? We define this as 2 pi upon lambda. We define this as 2 pi by lambda. And there is one more way of writing this, right? This is sometimes also called as angular wave number. It's also called as angular wave number. and we denote it by 2 pi by lambda, right? Where lambda is wavelength. Written it down. Now let us see some relation between, once again, between all of these variables, right? I'll write it here. Omega is 2 pi into frequency, or 2 pi upon time period of the wave. What is the time period of the wave? It is the time in which the wave travels by one wavelength. Let's say if wave was here, right? Its wavelength is lambda. When the wave travels to a new point such that this point A comes over here, right? And the wave looks something like this. See? Now this point A has moved ahead or progressed ahead with a distance of lambda, right? So the time in which this is happening is called as time period. The time in which any particle of the wave is getting displaced in one direction, right, or horizontal direction by lambda value, right? If it is getting displaced by lambda value in some time t, then that time t is called as time period. Is called as time period. I hope the concepts are clear, right? Atul, Anukriti?
Yes, sir.
Yes, sir.
Okay. So these are some basic concepts, right? Then we also have a relation between angular wave number and lambda, which we have just written. K is equal to 2 pi lambda, right? And how do we define a relation between lambda and t? Do you both know? We have something called as wave speed. We have something called as wave speed. Please jot this down, very important. Wave speed. Wave speed is given as v is equal to lambda, that is distance being traveled, upon time in which it travels that distance. Of course, see here, we told that this point is progressing ahead along with the wave, right, in time t, and it's traveling a distance lambda. So what will be the speed of the wave? It will be equal to lambda into t, lambda upon t, right? That is distance per unit time, correct? Now, what can we do? Let us do one thing here. We'll multiply divide by 2 pi. So this expression should become something of this sort, correct? Which is nothing but omega by k. Right or wrong? Atul, can we write this expression? Instead of 2 pi by t, I can write omega, right? Instead of 2 pi by lambda, I can write k, right? So wave
Yes.
speed can always be written as omega upon k. Can we write this, Atul?
Yes, sir.
Right. Please write this down, everyone. Take a note.
So how did you get the equation that lambda by t is equal to 2 pi by t?
I just multiplied and divided by 2 pi. See here, we had v. I'll write it again.
Yes, sir.
I have wave speed. Acha, did you get this term, that this expression, that v is equal to lambda by t? Could you get it until here?
Yes, sir.
Now
That I understand.
yeah, now multiply divide by 2 pi. Is this clear?
Yes, sir.
Now take 2 pi by t together. So you have 2 pi by t into lambda by 2 pi. Can you write it this way?
Yes, sir.
Now you can write 2 pi by t times of 1 by 2 pi by lambda. The concept is basically you can take numerator as denominator of denominator. So I've taken lambda
Yes.
below 2 pi. Is it now clear?
Yes, sir.
2 pi by t
Clear.
is omega, right? And 2
Omega.
pi by lambda is k. So
Oh,
v is equal to wave speed is given by omega by k, right?
yes, sir.
Oh,
Okay.
clear now? Pakka?
Yes, sir. Clear. Yes, sir.
Now let us see one more thing, right? It's called as displacement. What kind of displacement are we talking about when I write? Let's say I write an equation y is equal to a sine of kx plus omega t. What kind of equation displacement I'm talking about? Atul, this is the displacement of a particle in the wave. This is the displacement of particle, vertical displacement. So let's say I have a rope here, right? And I produce a wave in that rope. I produce a wave in that rope. So this value is y, right? This value is y from this central line. It is also called as line of zero disturbance or the central line. So from this line, the position of a particular point on the wave or a particle on the wave will be called as y, whereas this horizontal distance will be called as x. I'll repeat what I just said. Let's say I have a rope. I have a rope. Okay. Now I produce a disturbance in the rope, right? Let's say there are two people standing. One is over here, right? The other is over here, right? He wants to feel the wave. The other one wants to produce the wave. Let's say A and B. So A produces a wave, right? Which travels via this rope to the other end, which travels via rope to the other end. So this is a progressive wave, right? Generated by A. So I am saying that I'm trying to make you understand what do we mean by writing y? What is x here? That is what I want to create a picture of in your mind. So when I'm saying that there is something called as y, I mean if all of these are the particles which are undergoing or which are taking the wave forward, right? Then for all of these particles, you will have some value of y. For all of these particles on the rope, you will have some value of y and some value of x at a given value of time. At a given value of time. So let's say this is y. What is y? Y is the vertical displacement of this point. Let's say I'm talking about a point P. Let me encircle it also for the convenience of everyone. So let's say I've encircled this point P, which has a vertical displacement y, right? From the point of origination of the wave, from the point where wave has originated, then this distance x, this horizontal distance x, is the horizontal position of this point. Am I clear, both of you? Right? What do we mean by x and t? And this is a picture of the wave at any given time t. So let's say I was standing here as a cameraman, right? I was standing here as a cameraman. I took the photograph. I took the photograph of this wave traveling. So at any given time, at that time t, when I saw the wave moving in the forward direction, for this point I saw it is vertically above this line or this central line, which is also called as line of zero disturbance. You can take this down. This is called as line of zero disturbance. Right? So this is how we picture a wave. This y is the displacement of this particle, vertical displacement, and x is its horizontal displacement from the point where the wave has started moving, right? So this particle, what about this particle, right? This particle is actually oscillating only in vertical direction. See, this particle is not moving ahead. Does the rope move ahead? Atul, try and guess this answer. When I'm saying that I am sending a wave pulse or I'm sending a wave by the means of a rope ahead, so is one particle moving ahead or is the particle just oscillating about its position? So this particle here, let's say this particle here, did it come here or is the particle remaining at this point only? Try and tell this.
It's remaining
Does, it,
at
does,
that
does the x value of the particle change? Does the x value of the
no,
particle
sir.
change at all? If the wave is
No,
held
sir.
by two people or the rope is held by two people?
No, sir.
No, right? Here, one one person was on one side, other one is on the other side. So x value of any particle cannot change, but the x value of wave will change. That means if the wave was initially over for this x1, now that wave will be present at, or that condition of the wave will now be present at some other x, but still the point that we are talking about, let's say this was point P, then the point P will remain at the same x only. Point P will remain at the same x only, at the same x only, right? So if you want to take this down as a note, please take this. It says that all the particles, all particles here in the medium, so this is, I'm talking about case of transverse wave or any, or even the longitudinal wave. All the particles in the medium do not actually move, do not actually move or get displaced along with the wave. They just vibrate. They just vibrate about their mean positions, about their mean positions. Please write it down. About their mean positions. This is very important to understand that a particle is actually vibrating about its mean position as the wave is traveling in one particular direction, right? So that is, let us come back to where we were. When I say y, I mean that this y is nothing but the displacement, of the particle, which displacement? Vertical displacement of the particle, right? This is the vertical displacement of the particle. So Atul, tell me what will happen if I differentiate this y with respect to t. If I try to find out dy by dt, keeping x constant, what should I get the answer? Atul.
Velocity.
Yes.
The velocity of the wave in the y-axis.
So either you can basically term this as velocity of the particle. Write it down, everyone. Vp, or velocity of the particle. Because what is the displacement telling me? What is y telling me? Displacement of the wave or displacement of the particle? Displacement of the particle. Right? And we already know what is the wave speed. We know wave speed is omega by k. We know wave speed is omega by k, right? So velocity of the particle is therefore dy by dt, keeping x constant. Keeping x constant. Just take this down. Keeping x constant, right? Now, tell me, Atul, what should be the differential of this expression with respect to t? Yes.
So the a omega. Yes, v
Cos
equals to a omega. A omega cos kx plus omega t.
Right? Taking x constant. Now, when this is wave velocity, can you tell me what is the maximum value of wave velocity?
We'll equate it to 0.
Yeah. This is particle velocity. Can you tell me what is the maximum value of particle velocity? Yeah.
Yes, a omega.
A omega. So this a omega is the maximum value of particle velocity, right? So now we are coming to some important terms, right? Let me give you some definitions which will be required to solve this chapter. So this was a basic introduction, right? This was a basic introduction to the chapter waves, where we learned some points, right? This is how we express, any wave equation, right? Then we understood about a specific kind of wave called as progressive wave, right? So this is the equation of a progressive wave. If both have same signs, that means wave is moving in the negative x direction. If both have opposite signs, that means wave is moving in the positive x direction, right? Then we understood about different terms like angular frequency, like angular wave number, like wave speed. Wave speed is defined as omega lambda by t. With the help of Anukriti's doubt, we also understood how we understood that how V is equal to omega by k, a superbly important relation, super relation, right? Which you all should remember, right? Then we understood that when I write y is equal to a sine kx plus minus omega t, I am actually saying this y is the displacement of the particle. What displacement? Vertical displacement. So when I differentiate that, when I differentiate this y expression with respect to t, when I differentiate it with respect to t, all I'm getting is the expression for particle velocity. How is the particle velocity changing with time and x value, right? So this is what I get. Then Atul helped us classify that this particle velocity has a maximum value given as a omega. Atul, can you also tell me what is the value of wave velocity? So this was maximum particle velocity. Maximum particle velocity. What did we get? The value of wave velocity? Yeah, omega by
Omega by k.
a. Right, omega by
K.
a. Absolutely correct. Now, suppose I divide them. Suppose I divide them. Vp max upon V. What will I get? Tell me, Atul.
V max.
A omega upon
Then so a k.
AK.
K
Yes, that has to be remembered. That has to be remembered. Would you be able to remember this, Anukriti? The ratio of maximum velocity of the particle and maximum velocity of the particle and wave velocity or wave speed. This gives you a into k, where what is a? A is amplitude. A is amplitude of the wave, right? Whereas k is angular wave number. K is angular wave number. Concept clear?
Yes, sir.
Okay. Now we learned about these things. Now, there is something called as change of phase. There is something called as change of phase. So when I'm writing no, y is equal to, when I'm writing here, have a look, a sine kx plus omega t, right, plus phi. Let's say I'm writing this equation. So from this equation, I must tell you that this expression is called as phase change. This expression is called as change of phase or phase change. So I'm trying to tell you how does phase change depends upon change of x and change of time, right? So see here, this is how it depends. So phase change is given by in terms of, let us write it in terms of omega and t here first. It will be, of course, omega into delta t. And how can we write omega? Omega is 2 pi by capital T. 2 pi by capital T. Correct? Now, similarly, phase change is also given by in the terms of kx. See here. See, this is the way of learning it also. I'm writing phase along with omega t. I'm writing phase along with kx. So I am defining phase change in terms of omega and delta t. Similarly, I'm defining delta phi now in terms of just a second. Now I'm writing omega t in terms of k and delta x. K and delta x, right? K and delta x. So I have k given as 2 pi by lambda, right? And here is delta x. So see what I have done. First, I have defined phase change in terms of time change, right? First, I have defined phase change in terms of time change. Then I have defined phase change in terms of displacement, right? Or the path difference. So here, right, what are these values? Delta phi is called as phase change. Delta phi is called as phase change, right? Delta t is called as time interval. And delta x is called as path difference. The difference of path, right? Path difference. So to give you an example, what do I mean by path difference is time interval we all understand, right? Let us see then what is path difference. So let's say I have 2 points on the wave, or let's say some different points, right? Let's say it's a sinusoidal wave, okay? Now, let's say we have this point on the top of the crest, you know, and this point at the bottom of the trough. Can somebody try and tell me what should be the distance or the path difference between A, B, C, right? So can you tell me, Atul, and this is the point, let's say O. Atul, can you tell me if this is the entire wave, right, of length, of length, of length x, let's, sorry, of wavelength lambda, right? This entire value is lambda. So can you try telling me what is the, let's say I'll take one more point D here. Okay. What is the distance AD giving me? Yes. AD is giving me distance lambda.
Lambda by 2.
Lambda. See here.
Also AD.
AD is giving me lambda. Pakka.
AD is lambda or AC, sir.
I'll write it here once again. For the purpose of clarity, let us write it here once again. So I'm saying here I have a wave. Okay. Right. Now I say that consider that this is a very harmonic wave, right? Now let us see, or just okay. Now when I'm talking about waves and I say that the wavelength of the wave is lambda. What do I mean? This is what I mean. That the pattern repeats itself. The wave pattern, see here, the wave pattern is repeating itself after every lambda distance, right? This is x and this is y. I'm plotting a graph for a wave between y and x. And I'm saying that this is lambda. What does this mean? It means that half of it should be, Atul, half of it should be
Lambda by 2.
lambda by 2, right? How about 1/4 of it should be
Lambda by 4.
lambda by 4. So when I talk about the term path difference, now what do I mean? If I say points A, B, C, right? Let's say point D and point E. Let's say I talk about these 5 points. Then AB, the path difference between AB will be lambda by 4,
Lambda by 2. Oh, sorry, lambda by 4. Yes, sir.
right? Path difference between AC will be equal to
Uh,
lambda by
Lambda by 2.
2. Path difference between AE, AD will be, first of all, path difference between A and D. Tell me how much should it be?
Lam 3 lambda by 4.
Yes, 3 lambda by 4, right? Path difference between AE should be
Lambda.
lambda. Okay. Anukriti, tell me, path difference between CE,
Lambda by 2.
lambda by 2. Path difference between BE,
3 lambda by 4.
very good, very good. So now I hope both of you are clear with the concept of path difference, right? What is path difference? Correct, Atul? Anukriti?
Yes, sir.
Okay, okay. So this is what path difference is, right? Now, there are some simple terms which you all should know, right? There are some simple terms which you all should know, and that is going to help you, right? So one is the velocity of wave, or the velocity of speed of wave, right, on a transverse or stretched wire. So that, well, speed is given by under root of t, where t is tension, upon mu, where mu is the mass density or linear mass density, which is mass per unit length of a string. So what I'm saying, we have, suppose, a string in this pattern, a stretched string, let's say string of a guitar or things of this sort, right? Let's say we have a stretched string between two walls. If we have a stretched string between two walls, then velocity of the wave which is traveling on this stretched string will depend upon its tension, right? T will be called as tension and mu will be called as linear mass density, which can be written as m by L, and we can also write this as, in different other terms. We'll see that when we come across it, right? Just a second. Or maybe let's try doing it. Suppose I divide it by volume and multiply it by volume of this row. So what will I get? Mass per unit volume. Atul, mass per unit volume is given as
Mass or density.
density, and volume per unit length will be given as giving area, right?
Area.
Area A.
Yes, sir.
But what is this A? What is this A? A is the area of cross section. That means if this rope, if you see this rope, let's say if this is the kind of rope we have, right? And you see it from here. If you see it from here and this rope has a radius R, then this section, which I'll be painting in red, this section has a surface area A. This is called as cross-sectional surface area. When you cut it perpendicularly, right? Therefore, this is called as cross-sectional or cross-sectional area. Are we clear on this?
Yes, sir.
So this linear mass density can be given as mass per unit length or rho into A. Are we clear now? Pakka?
Yes, sir. Yes.
What is this? This is the speed of the wave. Anukriti, are we clear?
Sir, can you repeat it just once more?
We are talking about
The
speed of wave. We are talking about speed of wave on a stretched string, and on a stretched string, only transverse wave is formed, right? So we are talking about speed of wave on a string, and I have said that the formula is V is equal to under root T by mu, where T is tension, mu is linear mass density, right? We write mu is equal to linear mass density. So linear mass density is mass per unit length. It is given by mass per unit length. So I have done no rocket science. Just I have multiplied divided by volume. I have multiplied divided by volume. And mass per unit volume is nothing but rho. It is given by rho. And volume by L gives me area. Am I clear?
yes, sir. So
Pakka.
you only did it for the denominator, not the numerator.
Sorry?
You only multiplied velocity for the mu part, not the t part.
No, I'm not multiplying velocity. I'm multiplying volume.
Sorry, volume.
Yeah.
Sorry.
So we have V is equal to
If
volume, right? And I'm writing this. I'm just talking about mu. Okay.
mu, not v.
See here.
Okay, sir.
Not T.
Okay.
See here. I'm talking mu is equal to mass per unit length. Are you clear with this? Linear mass density.
Sir, I understood that, sir.
And I am multiplying volume in the numerator and denominator, right? Now mass per
Yes,
unit
sir.
length is giving me,
Density.
mass
Density,
per
rho.
unit length. Mass per unit length was giving me
Mass, mu, which is linear mass density.
linear mass density, and mass per unit volume will give me density or rho, and volume per unit length will give me area.
Yes, sir.
Clear now, Pakka?
Yes, sir. Clear.
I've just basically all I've tried to do is express mu in terms of rho and A, just that, right? Now, this was speed of the wave on a string, right? Now, let us see the speed of wave in any ideal gas or any gas, right? or any bulky medium, right? So speed of wave in a bulky medium or in a bulk medium. Bulk medium means, let's say, water, right? Let's say air, right? In a bulk medium. So there the speed of wave is given as, v is equal to, or even a steel bar. Let's say I have a steel bar, right? So basically you can have three ways of writing this. You can have three ways of writing this. One, in solids, speed is given as v is equal to under root of y by rho, where what is y? Y is Young's modulus, rho is density. Are we clear with this? Young's modulus, right? Then next one, if we talk about liquids, just replace Young's modulus, by bulk modulus, B, for liquids, right? What is this? All of these are different expressions for speed of the wave, right? Speed of the wave. So this is bulk modulus. Right? Now let's say I talk about gases. So in gases, there are two ways, right? Two people who gave these formulas. One was Laplace and the other was Newton. So one is called Newton's formula. Newton told this formula as V is equal to under root of P by rho, where what is P? P is the pressure. Right? Of course, rho is density, right? Of that medium. But actual results were actually not matching with this. Then there was another scientist who came, who was Laplace. So Laplace told that if in Newton's formula, I'll just add one term, that is gamma. Do you remember from the thermodynamics chapter what gamma is? Yes, Atul, what is gamma called as? Gamma is adiabatic
adiabatic constant.
Given as Cp by C.
Yes, Cp by C.
Right? Correct. Adiabatic constant. Now we have written these two equations in terms of pressure per unit density, and here gamma into pressure per unit density. Suppose I try to recall what is ideal gas equation. Mahila, can you tell me what is ideal gas equation? Yes, PV is equal to nRT, right? Easy. Now, let's say I want to write this number of moles in terms of mass, or let's say I can write this as, what is moles equal to? If I suppose I want to turn this equation, PV is equal to nRT in terms of moles and in terms of weight and molecular weight. What can we write this as? Mass per unit molecular mass, right? Number of moles can be written as mass per unit molecular mass, right? Am I right, Atul?
Yes, sir.
Now I can write this as P into M is equal to small m, that is mass, upon volume. What does mass by volume give me, Atul?
Mass of density.
So I can write Pm is equal to rho RT. This is also a form of ideal gas equation. Pm is equal to rho RT, where what are different variables? P is pressure. What is M?
Pressure.
Molar mass.
Molar mass.
Right? Molar mass. Let's say, for example, what is molar mass? Let's say I'm talking about nitrogen, N2, right? Then for nitrogen, we have 7 and 14, so 28 gram per mole. 28 gram per mole is the unit. Do you remember? I taught you all that we need to convert units whenever substituting in the equation. Atul, do you remember this?
Yes, sir.
Okay.
In terms
in terms of kg. Do you remember? So when I
kg.
told,
Yes,
when I
yes,
say
sir.
that the molar mass is, say for nitrogen, it is given by 28 gram per mole. So whenever we are substituting, we need to actually substitute in terms of kg. So we can also write this as 28 into 10 to the power minus 3 kg per mole. Correct?
Yes, sir.
Okay. Now, this was about P and M. Rho we know. Rho is density of the gas. Rho is density of the gas. Of course, we know what is R. R is known as universal gas constant, right? And has a value of 8.314 joule per mole per Kelvin. Very important to remember units. Many people forget and do not remember units. Please make sure you do remember it. What is T? T is absolute temperature or temperature in Kelvin. Very important. Kelvin. Some people also forget this, right? We do not have to. So we need to remember that PM can be written as rho RT. Now tell me, Atul, what can I write instead of P by rho? What will be the value of P by rho from this equation? Tell me. Yes.
P by rho equals to RT by M.
RT by M. Let us substitute that over here in this equation. We have P by rho. Here also we have P by rho, right? Anukriti, what should be the answer? V is equal to under root of P by rho can be written as under root of RT by M, right? Anukriti,
Yes, sir.
this is the speed given by Newton's formula. Now, how about the other one? That is Laplace formula. Tell me.
Add a gamma to the numerator.
Yeah, so we have V is equal to gamma RT by M.
RT by M.
Right? Now, what does this tell me? It tells me so much about velocity, right? Suppose I'm talking about two gases. Suppose I'm talking about two gases. Let's say what kind of questions you get. I'm trying to tell you. Let's say you have one gas, right, which is nitrogen, and the other gas, which is, let's say, argon. What is the difference between them, Atul? This one is diatomic or monoatomic? Nitrogen.
Diatomic.
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 What is argon? Mono or dia?
Monoatomic.
Do we know the gamma values for both of them?
Gamma for mono. Di is 5. No, degree of freedom is 5.
And for mono, degree of freedom is
Degree of freedom is 3.
3. Calculate the different values. So for here, degree of freedom is 2. Here, degree of freedom is 1. Right? Now, you have, just a second, class. You have F is equal to 1, right? For mono, sorry, F is equal to, pardon me, I think I have written it wrong. We have just understood that degree of freedom is 3 for a monoatomic gas and is 5 for a diatomic.
5.
Correct?
Diatomic.
Yes. Now let us calculate gamma. Gamma value for
7 by 5.
Yeah, we have calculated it.
Diatomic is 7 by 5. Yes, sir.
Yeah. So it will be 2 by 5. 1 plus 2 by 5 will be 7 by 5. Correct?
7 by 5.
So gamma
Yes,
is 7 by 5 for a diatomic. What about monoatomic? Tell us.
5 by 3.
Very good. 5 by 3. We don't have to forget this, right? Keep it in your memory always from now, right? Now, suppose I'm telling you, find out the ratio of speeds at the same temperature. Find out the ratio of speeds at the same temperature. Speed of what? Speed of a wave. Speed of a wave in nitrogen and speed of the same wave in argon. So see here, if I'm talking about same temperature, then RT by M will be, R and T will be same. What will be different? Molar mass and gamma value. Right or wrong? Atul?
Yes, sir.
Right? So,
yes, sir.
So whatever, let's say we are given with the argon molar mass. Similarly, we are given with nitrogen molar mass, right? So in this way, we'll be able to find out what is the velocity for the two, right? What is the ratio of the velocity for the two, right? This will be gamma by m for gamma by m for nitrogen, and in the denominator we'll have gamma by m, gamma upon m for argon, right or wrong, Atul?
Yes, sir. Right,
Clear?
sir.
Pakka?
Yes, sir.
Properly?
Yes, sir.
Okay. Are you clear, Anukriti, with whatever we have read in today's class?
Yes, sir.
Okay.
Clear.
So whatever we have read, these are some basics, right? Some basics. Although the questions which I will be now sending you as assignment will consist of everything. It will consist of some questions from stationary waves also, some questions from sound level also, intensity based questions, right? Some questions will also be from the topic Doppler effect, right? You may be able to do it, you may not be able to do it, no worries, right? But then we'll of course see about all of this in today's evening class while solving this question, right? So the questions which I'll send will consist of whatever we have read until now, right? It will also consist of questions from superposition of wave, interference, right? So I think I've sent you both, like all of you, a document, right? Am I correct? Patul, am I correct?
Yes, sir. Yes, sir.
So please have a look at it, right? Please have a look at it. Today, let us today I'll be sending you some assignment questions which will be based on those documents. So with every question that we consider today, we'll also see the concept, right? We'll also see the concept before considering that question. Am I clear? Right?
Yes, sir.
Okay, then let's continue beyond this in today's evening practice session. So thank you very much. Thank you for being a part of the session. Anything that you would like to ask, yes, let me know. So today we started with all of this, right? We understood what, so here is the beginning of the chapter, right? We started with recollection from your past, right? Then we went on to understand the distribution, post which we saw how waves are defined, right? Or classification of waves. I think I've written classical here, it's classification, okay? Classification of wave. So this was classification of waves. Then we saw in the next one, if two like we saw what a progressive wave looks like, especially a sinusoidal wave looks like. We understood how we define the speed of the wave and particle velocity and their ratio, right? Maximum ratio of maximum particle velocity is to wave speed, right? That gives you AK. Then we saw the difference between phase change and time interval and path difference. We understood using different examples what path difference is. Then we have also seen the speed of wave, right? Then in different cases, in solids, liquids and gases, we have also seen Newton's formula and Laplace formula for finding the speed in case of gases, right? Then we saw one example of that. In the evening class, we'll be considering questions on Doppler effect, waves, right? Longitudinal and stationary waves, right? And beats. And the questions will be very simple, right? So try them, try them. Otherwise, along with the questions, we'll also consider the concept in the coming assignment class, right? Any doubts, anyone, feel free to let me know. Anyone, any queries? Anukriti?
No, sir.
Atul, is it clear what
No,
we
no,
have read? Yeah, Anukriti, you were saying something.
No, no, sir.
no, sir. I said no
Okay.
queries.
Okay, clear, right? Okay. Thank you then. Let us catch up today in the evening and continue with the syllabus from this point, right? Along with the questions. All right then. Thank you, Atul. Thank you, Anukriti. Let us meet in the evening class. Thank you very much. Thank you.
Thank you, sir.
Thank you, sir.